What are auroras, the heavenly lights, and what causes them? Auroras are visible almost every night near the Arctic and Antarctic circles, which are about 66.5 degrees north and south of the equator. In the north, the display is called Aurora Borealis or Northern Lights. In the south, it is called Aurora Australis or Southern Lights. An aurora is a natural light display that shimmers in the sky. Colorful blue, red, yellow, green, and orange lights shift gently and change shape like softly blowing curtains. Auroras are only visible at night and usually only appear in lower polar regions. The origin of the aurora begins on the surface of the sun when solar activity ejects a cloud of gas. Scientists call this a coronal mass ejection. If one of these reaches Earth, taking about 2 to 3 days, it collides with the Earth's magnetic field. This field is invisible, and if you could see its shape, it would make Earth look like a comet with a long magnetic tail stretching a million miles behind Earth in the opposite direction of the Sun. When a coronal mass ejection collides with the magnetic field, it causes complex changes to happen to the magnetic tail region. These changes generate currents of charged particles, which then flow along lines of magnetic force into the polar regions. These particles are boosted in energy in Earth's upper atmosphere, and when they collide with oxygen and nitrogen atoms, they produce dazzling auroral light. What happens in an aurora is similar to what happens in the neon lights we see on many business signs. Electricity excites the atoms in the neon gas within the glass tubes of a neon sign. That's why these signs give off their brilliant colors. The aurora works on the same principle, but at a far vaster scale. The aurora often appears as curtains of light, but they can also be arcs or spirals, forming lines of force in Earth's magnetic field. Most are green in color, but sometimes you will see a hint of pink. Strong displays might also have red, violet, and white colors. The lights typically appear in the far north, the nations bordering the Arctic Ocean, Canada, Scandinavian countries, Iceland, Russia, and the state of Alaska. And of course, the lights have a counterpart at Earth's south polar regions, though there is less land at high southerly latitudes for people to witness the displays. So today, the mystery of the aurora is not so mysterious as it used to be. Yet people still travel thousands of miles to see the brilliant natural light shows in Earth's atmosphere. And even though we know the scientific reason for the aurora, the dazzling natural light show can still fire our imaginations to visualize fire bridges, gods, or dancing ghosts. The colors in the aurora were once a source of mystery throughout human history, but science says that different gases in Earth's atmosphere give off different colors when they are excited. Oxygen gives off the green color of the aurora, whereas nitrogen causes blue or red colors. Auroras occur on other planets too. All that's required to make an aurora is an atmosphere and a magnetic field. Auroras have been seen in the atmospheres of all the gas giant planets, since these planets all have robust magnetic fields. Jupiter's magnetic field is 20,000 times stronger than that of Earth, so the giant planet's auroras are far brighter than the ones that blaze in our skies. Northern lights are happening 24 hours a day, 7 days a week, 365 days a year. But that doesn't mean they are easy to spot. You need to be at the right place at the right time. The best place to see the northern lights is any destination in the auroral zone, the area within an approximately 2500 kilometers radius of the North Pole. That's where the aurora most frequently occurs, though the phenomenon can creep farther south during particularly strong solar storms. The best time of year to see the northern lights is between September and April, when the sky gets dark enough to see the aurora. The most action usually happens between 9 pm and 3 am. Keep the moon phases in mind, as a bright full moon might fill the night sky with light. Auroras are beautiful, but the invisible flows of particles and magnetism that go on at the same time can damage our electrical power grid and satellites operating in space. This is why scientists are so keen to understand the physics of aurora and solar storms so we can predict when our technologies may be affected. So, the bottom line is, when charged particles from the sun strike atoms in Earth's atmosphere, they cause electrons in the atoms to move to a higher energy state. When the electrons drop back to a lower energy state, they release a photon, light. This process creates the beautiful aurora, or northern and southern lights.